This is RD Sharma solution. We are taking probability of class 12th. The exercise is 31.5. A bag contains 6 black and 3 white balls. Another bag contains 5 black and 4 white balls. If one ball is drawn from each bag, find the probability that these 2 balls are of the same color. So in order to understand this, let's make a figure. So this is our first bag. This one is another bag. So we have 6 black and 3 white balls here. How many in total? 6 plus 3 is 9. In the second bag, let us call the first the bag as 1, second as 2. In the second bag, it is given in the question 5 black and 4 white balls are present. The total in the second ball also counts to 9. Now if one ball is drawn from each bag, so when you draw the ball and the other ball from the second box of bag, these bags are independent. So whatever you draw from one is independent as or has no relationship with the other one. And similar for the second one also. So the first one black, second black. First one white, second one white. First one black, second one white, and first one white, second is black. So these are all possibilities that can come. So let's write it in a formal way. B1, B2. First black and second black. First white, second white. First black, second white. First white, second black. White and black are the last one. So these are only 4 combinations that can come. Now the 2 balls are of the same color. That is, same color means except this B1, W2 and W1, B2. Others we require. Same color means black, black and white, white. So the first and second. So this will be how it will be written. Probability of both balls are black and probability of both the balls are white. So both black, both white, first and second are the actual favorable cases here. Ball of same color. What does it mean when we write both black? It's basically B1 and B2 and means intersection. So we'll write probability of B1 intersection B2. These are independent events. So we can write PB1 multiplied by PB2. Similar for the second logic. Probability of both white. So PB1 intersection B2 and second one is both white. So W1 intersection W2. That is either of the whites or first white and second white. So we have PW1 multiplied by PW2. So this PW1, PW2. So we have PB1 multiplied by PB2 as the first one and second one PW1 multiplied by PW2. So we need to find out the probabilities now. The probability of getting a black and probability of getting a white in the first one. I'm writing it as B1, V1, the W1 just to represent that they are coming from the first bag. 9 remains in the denominator because these are total cases. Blacks are 6, whites are 3. So 6 by 9 and 3 by 9 are the probabilities for the first bag. Second one again, PB2 and PW2 we are writing. Denominator remains the same. 5 plus 4 is 9. So the total number of cases are 9. What are the favorable cases for black in the second bag? It's 5. Let's write 5. The second one is 4. Now we have got all the values and we are going to write it here. PB1 is what? 6 by 9. PB2 is 5 by 9. PW1 is 3 by 9 and PW2 is 4 by 9. So 30 by 9 9s are 81. Fourth is a 12 divided by 9 9s are 81. So 42 by 9 into 9 has come. 42 by 81. Now these are multiples of 3. So you get 14 divided by 27. 14 by 27. Now what I told you was quite in detail, but this is how you are going to write it. If you have less mark carrying question like this, otherwise you have to explain everything. A bag contains 3 red and 5 black balls, and a second bag contains 6 red and 4 black balls. A ball is drawn from each bag. Find the probability that one is red and the other is black. So here we have the first bag, 3 red plus 5 black. First one is this one. Second bag is 6 red and 4 black balls. 6 R and 4B. A ball is drawn from each bag. One is red and one is black. The probability needs to be found out. From the first one, red can come. The second can give also the red. So R1, R2. 1 and 2 represent first bag and second bag. First one gives red. Second one gives black. First Black one comes, second one red, and first black and second also black. So these are the four combinations or four possibilities that can come. One is red and other is black. So one is red, one is black means it's not given that first has to be red and the second has to be black. It is given red black or black red. So we will take the second and third options here. R1 B2 and B1 R2. So the first one is saying one is red and means intersection. One is black. So what is this probability? Probability comes like this. Red and black. So probability of red and black. Red 1 and black 2. But black and red can also come. First one red 1, second one black 2. This already done. Coming to the second part, which is first black and second red. First gives us black. So let's call it as black 1 and second comes the red. So red 2. This is B1 intersection of R2. Now these are independent events. We can write it as PR1 multiplied by PB2. Here we can write PB1 multiplied by PR2. Now let's find the probability. So the probability of R1 will find out, B1 will find out. Total number of values are 8. So 8 goes in the denominator. Here also we'll find PR2 and PB2. 1 and 2 representing that they are coming from first and second bags. Total is 10 in the second case. Total is 8 in the first case. That's why I've written everything in the denominator. These are total number of cases. Favorable cases for red in first is 3. Black in first case is 5. 6 in second bag and 4 in 10 bag, red and black respectively. Now as we have found out the probability, we'll just replace it here. 3 by 8 for PR1, B2 probability 4 by 10 plus 5 by 8 B1 probability and R2 probability 6 by 10. So this becomes 12 divided by 80 and then plus 30 divided by 80. So this becomes 42 by 80 and when you compute this it will be 21 divided by 40. This is your final result. So this is how it will be done. But if this question carries more marks, then the explanation I gave should also be incorporated or be considered. 2 balls are drawn at random with replacement from a back box containing 10 black and 8 red balls. Find the probability that both the balls are red. So we have a box. In this we have 10 black and 8 red balls. Now we have to draw 2 balls with replacement. That is, this is the condition. This is the question of independent events. If replacement is being carried out, this is the question. No replacement, conditional probability question. So both are red. That is, first black can come, second can be red, then red can come from the first drawing and the second will be black. First black, second black ball, and both the balls which we are picking up are red. So these are 4 possibilities. So let's call it as 1 or 2, 1 and 2 because there are 2 balls being drawn one by one or say simultaneously also, together also. Now probability of red is in both the ones are only R1, R2. It can be R2, R1, it can be R1, R2. They both are same. So these are independent event. We can multiply them separately. So PR1 multiplied by PR2. And what is the PR1 and PR2? See, the R remains the same. Probability of red remains the same because there is a replacement. I am writing it separately, but they are similar. PR1 and PR2 are same. The denominator is total number of balls are 18. So write that in the denominator. Numerator has how many? 8. So 8 by 18. So 8 by 18 and 8 by 18. You will get 16 by 81. Basically it's 64 by 324. So this was a very simple question that can be followed. 3.2 also will be done in the similar way. Now we have again the same box which contains 10 black and 8 red balls. We have to find out first ball is black and second is red. Now there are 2 balls being drawn. The first one can be red, second can be red, first can be black, second can be black, first can be red, second can be black, or both can be. So these are both red, both black, then the inversion, that is red black or black red. I'm writing it as 1 and 2 just to show that these are 2 separate balls. But since the replacement is being taken care and we have to find out that the first is black, it's fixed that first has to be black and second has to be red. What is the probability of getting a black? Total is 18. What is the probability of getting a red? See, it's 18 in the denominator. Please remember black, B1, B2 or P, R1, R2, the probability remains the same because replacement is going on. What is the probability of black and red together? B1 intersection of R2. That is black coming from the first draw, second draw giving us red. So P B1 multiplied by P R2 because these are independent events. Probability of B1 we just found out, it is 10 by 18. Probability of R2 is 8 by 18, and this comes out to be 80 divided by 324, which comes out to be 20 by 81. Now this is how this will be done. Now similar question, but here one of them is black and other is red. Same thing. I need to explain all of this. If you have done 3.1 and 3.2, this question will be easier for you. The scenario here is the same scheme. 10 is black and 8 is red. In this, one ball is being drawn, second is also being drawn, and these are independent events because replacement is going on. Whatever is being taken out has been put back before the other ball can be picked up. So both can give you black, both can give you red. First can give you red, then followed by black. First can give you black, followed by the red one. Now the question being asked is, one of them is black and other is red. It's not said that first has to be black and the second has to be red. No, it can be R1, B2, it can be B1, R2. First red, second black, first black, second red, and first red and second black. So let me just change this, the rounding. I have to make this one as the probable inclusion. So P R1 intersection B2 plus P B1 intersection R2. Since these are the independent event, we can multiply them. So let's find out the probability first. Whether the first time or the second time, probability of red remains the same, and this is equal to probability of red 1 and red 2 both. Probability of black balls first or second time. The total balls are 18, so denominator will be 18. Here also, first black or second black, the denominator remains the same, it will be 18. And what is the favorable cases for red? There are 8 reds, so 8 by 18. Black are there, so 10 by 18. Now these are independent events, so we can write them separately. PR1 multiplied by PB2. First red, second black. Here first black, second red. So PB1 multiplied by PR2. What is PR1? It's 8 by 18. So these both probabilities, PR1 and PR2, as I suggested, they remains the same. So 8 by 18, 8 by 18, I'm writing here. PB1 and PB2 also remains the same. So I'm writing it here 10 by 18 and 10 by 18. So when you compute this is just twice of 8 by 18 multiplied by 10 by 18, which gives you 80 by 324 two times. This gives you 40 by 81. Now this is how this will be done. And this is a good question, and these are 3 parts actually we have done. This question will take for the next discussion. Thank you so much. Have a good one.